Hey everybody, how you doing? This is the second video on using integration to figure out the area between two curves. I'm going to jump right into the problem. So in this particular problem, I have a cubic function and I have a linear function. Now, I have to enter in the functions, find the intersection points, plot them to see what's going on, and then finally compute the area between the two curves. So the setup. Make sure I clear the variables that I'm using. I'm going to double check my two functions that I have entered. They look right to me. I'm going to evaluate them. Now the intersection points. Intersection points is always the solve command. Well, kind of almost told you the truth there, because the solve command, the answers don't look nice. So I'm going to use nsolve instead for this particular. And I wind up getting 3 intersection points. They come in pairs. I have the first and the middle, that's a pair. I have a middle and the last, and that's a second pair. So let's see how I can use these. So I'm going to plot these. So what I'm looking at here is I'm going to plot the two functions. I'm going to plot the f of x function. I'm going to plot the g of x function. And now x, where should x go from? That looks like maybe -3 to 3. Does that look good? That contains all the intersection points. I'm going to evaluate this. Looks like I have a good picture here. So I have 1, 2, 3 intersection points. So if I notice in the first region, I have the cubic function, which is f. That's above the linear function. And in the second region, I have the linear function on top of or above the cubic function. So this area, I'm going to have to break it up into, using those 3 points, into 2 regions. So let's see, I have this point and this point. Or sorry, this x coordinate and this x coordinate. So let me set up the first region. So the first region, I know I'm going to integrate. And it's going to be f of x minus g of x, because that is the cubic function minus the linear function. And I'm going to go x from, well, probably the easiest way for me to do this is to copy this. I'm going to copy this, put it in here, and then notice there's a little accent mark. I'm going to get rid of it. I'm going to come over here and go back up. I'm going to copy this one. I'm just doing a Control C or a Command C on a Mac. I'm going to get rid of the accent mark. I'm going to close them up. And that's the first region. Let me evaluate to see. Okay, that's pretty good right there. Now I need the second region. Well, the second region is going to be the linear curve, which is g, minus f, which is the cubic function. So for that particular one, I'm going to do it right below this. I'm going to integrate again. But this time I'm going to do g of x minus f of x. And my x is going to go from, well, let's just recopy this, just to make sure. From that bound, that's literally this intersection point right here. Look, it's about -0.44. That's about right. And I'm going to go all the way to this intersection point here, which is a little less than 3. 2.83. I'm going to copy that again. Put it down in here. Again, get rid of the little accent point. I'm going to close up my curly braces and then finally close up the integrate. So I wind up getting these two. Now, one thing I can do is, well, I'm just going to call this A. I'm going to call this one B. I'm just going to put A equals and B equals. So when I go down here, if I do A plus B, it's going to calculate that sum automatically for me. So now I have the area of region 1, the area of region 2, and the sum, the total area between the two curves. So just a quick little recap again. I first enter in my functions. Don't forget the clear command. I'm going to use the solve command. Well, in this case, I use the nsolve command because, well, the answers didn't look nice. I'm going to plot this so that my plotting range contains the 3 values, or however many intersection points that we have, just so I get an idea of what the picture looks like. I have 2 regions, and I have to determine the top function and the bottom function, and make sure that I'm subtracting in the right way. The top minus the bottom, the big numbers minus the little numbers. And I find I have 2 regions here, and they both look, the setup looks very similar, except for the top and the bottom, f of x minus g of x, and then g of x minus f of x. Those change. I know I'm going to have to add them together, so I added an a equals and a b equals. And if you notice, a and b, they change colors. They were blue. Now they're known, they're black. And this third output, that's good to 4 decimal points. I hope that was helpful. If you have any questions, let me know. Have a great day. Bye.